So I'm Ben Francis. I'm going to yabber on about Docker just a little bit. This will be a high-level overview. It's kind of slanted toward Linux, but we'll talk about Windows versions of Docker and Mac OS X and everything. A little bit about me. First heard about Docker about 4 years ago at a Linux user group meeting in the upstate. Certified in Security Plus and Linux, and I'm a serial presenter. So, all right. So, why is Docker and container technology and all this stuff taking off at this time in history when we had BSD jails in 1979 and Solaris zones later and OpenVZ in the 90s? Well, it's basically Moore's law. Performance going to double every 2 years. Gordon Moore predicted in 1965. He later amended it in 1975. And then another guy named David House says that actually your performance is going to double every 18 months because the cost can be chopped in half, and you're going to be able to afford more chips and all that. So the popular analogy is that if you took cars and computers in 1965 and extrapolated it out today, the car would get 300,000 miles would go 300,000 miles per hour, get 2 million miles per gallon, and it would cost 4 cents. So,
hey Ben.
Yes.
Completely unrelated to the talk that you're giving.
Oh,
you brought up Moore's law. Have you seen? Because I honestly haven't looked, but have you seen any changes with Moore's law and any of the corollaries?
It's starting to flatten out.
Well, based on Meltdown and these sorts of things where you see that they were cheating on performance and now are getting caught behind it, if that's...
Yeah, it definitely, to me, it seemed like Intel was cheating on performance and sacrificing battery life just so they could read that extra execution and try to predict it. And they weren't just doing one at a time; they were doing 4 and 5 at a time. So the chips were getting hotter and hotter, and battery life was getting lower and lower. But Intel had a 30% gain on AMD that whole time, and then turned out they were cheating big time. Now I don't know that AMD wasn't cheating, but they said it worked. Maybe they hit it better. I don't know. We'll see. But anyway, servers, computing, everything's getting cheaper. We're all hurtling toward the AI apocalypse where the machines get smarter than us and decide we're not necessary anymore. And then last thing you'll see is a drone above your head. So that's just an opinion, of course. And the industry progression as far as servers and virtual machines and all this, it's going like this as I see it. We started out with physical servers, and I remember this clearly about 15 years ago, working in the Durham and we need a new application. Well, we need a server to run out, so we run out to Dell and buy a whole server just to run this application, rack it and stack it and get it all connected, and then at the end of all that, server utilization was about 1%. And that was true of all the servers in the rack. And then one of the smart server guys said, "Well, hey, let's not do that anymore. Let's get VMware and decommission a whole bunch of servers, put them all on one server, and then utilization of that server went up to like 60 or 70%, which is what you want." So that was a smart deal. And then so physical servers gave way to virtual machines. Virtual machines gave way to containers about 4 or 5 years ago. And before that, we had BSD jails and Solaris zones and OpenVZ. And then that is moving to microservices today. And then we even have this thing called serverless computing, where it gets even not just going down to service level, but below that to function level. And so that's all out there, but most of us are still playing around here at virtual machines right now. Okay, and so remember in the video, they were talking about, enterprise is still running Red Hat 5. I got one of them. 1,200 packages on it. It's got about 20 gigabytes reserved just for the operating system. And then you throw Nginx and JBoss on it, and MySQL, of course. Can't do without MySQL. And it ends up to be a giant, hairy 20 gig ball of target that somebody can just aim their gun at, and they're probably going to hit something. So that's the big mess we're currently in. But that all that mess can be containerized down to a 7 megabyte Nginx container and a 7 megabyte MySQL. So 20,000 megabytes goes down to 14.
So how
with containers.
Just a quick question there.
Yeah.
So being MySQL, how do you deal with the dynamic size of data that's in?
Right. So the data is not going to be in the container itself. It's going to be on an NFS share. Maybe it's on the host box itself on a separate drive that's mounted by the container inside the container. That answer the question?
Yeah.
Okay. Right. So there we go. Yeah. And oh yeah. All right. So Docker is crap because you.
It's on the It's now. It will now be on the internet. So that must be true.
It absolutely is, because the first hit is free. All you got to do is do these two commands. If you got I know most of your Windows here, and you can fire up Ubuntu and a VM. Those two commands are all you need.
I feel like I'm being sold drugs.
The sudo is not capitalized, by the way. It's small s. It's just that's just the well, actually LibreOffice. But yeah, that's it. I mean, this is going to install Docker, and Docker run is going to say, okay, the name of this container is going to be test MySQL, and this last part right here says, oh, we need MySQL. Go pull it down from the internet and run it. So therein is the security concern for Docker. I mean,
because running arbitrary code isn't a problem at all.
Yeah.
This is fun.
You got it from GitHub, though.
So yeah, you might not want to just do that. I mean, that container, you got a pretty good bet, like 99%. That's a good container. But well, it's a security group, and things are coming out every day, so you might have a guy in the middle, changing the code on it. All right, so the enabling technologies for Docker and containers in general was a change that evolutionary changes that were put into the Linux kernel, and these evolutionary changes were namespaces, C groups, and the copy and write file systems, or support for that. Namespaces basically allows processes to have their own naming structure and everything, so they don't conflict with everything else on the system. C group stands for control groups and gives a container separate CPU, memory, disk, all the things that you would normally associate with a physical server itself or a VM. It's just, okay, this is going to be what this container owns, and it doesn't get more than that. Copy and write file systems, best known by the ZFS file system from Sun Microsystems, which is now Oracle. That is the enterprise-ready file system that's not going to lose data. Best example of copy and write, which is also Btrfs, native to the Linux operating system. And there's some others. I can't remember them right now, but These are the enabling technologies that allowed Docker to just explode on the scene in 2013. Immutability. Take nothing else away from this presentation. It's this right here. One container running on one service, on one port, with a read-only file system. I don't know about you, but it's pretty hard to hack a read-only file system. The hack would have had to been there before you ever got the container, which is a risk, but still, if you can trust the source from where it's coming, then this is what you want. You don't even want to be able to jump into the machine and do things. You don't want SS. Some people build containers with SSH in them to allow. SSH is the equivalent of Windows RDP. It allows you to get into the container and look around and all that. No, you don't want to do that. You just want to build a container, and if it's not working for you, you just kill it and rebuild it. Because the startup time for these containers they're measured in microseconds. Really, it doesn't have to copy the entire file system over to a new container. No, it uses copy and write technology to just say, oh, you want this? Well, it's already over here. We're just going to use that, and boom, and it starts up. So yeah, it's not hack proof, but it's pretty hack resistant.
So you can't get in there and modify. Well, this service is read only. I want to make it right.
Yeah, it's just a big ball of unmutable code. It doesn't have to be that way. I mean, you could put it on. It's container technology. You could write to it. You could even put a database inside of it, but why do that? You want your storage to be external to the container, just so you can kill the container and rebuild it. Maybe with a little bit different config. Maybe you increase the processes from the standard 1024 to 8000 or something like that, or the number of files that are allowed to be on the system. Yeah, something like that. You just change your config, rebuild the container, hey, everything's happy again.
So all that configuration that happens before you spin up that container.
Yeah.
And then once that container is up and running, it's static. It stays that way.
Yep, and that's exactly what you want.
And that's something we've seen in some of the things that we've done or we've had. You've got like a vulnerability in a service, and behind the scenes, we've had people that are like, oh, well, I'll just rebuild the service or I'll just restart it.
Yep.
Well, the vulnerability is still there, so they actually have to go back and patch their base container or their.
Congratulations, you restarted the vulnerable service.
Their configuration
exactly.
can push that out then with a new setup. But even at that, they've patched it one place and then they can actually execute that as many times as they need, and as many like Nginx servers.
Right.
They can be up and running in seconds once they patch that base.
Absolutely, and that's all the domain of CI/CD, continuous integration, continuous deployment. So that is all a thing because of this. You got to be able to have a process to say, oh, okay, this package is old, needs to be updated. We got to update it, and we got to rebuild all the containers in the environment. And it's not terribly easy to do. You got to have a process. All right. So Ubuntu 18.04, a Linux distribution based on Debian, came out last month. That's what the 4 is for. 4th month of 2018. You see Ubuntu, they're all named that way. So and they'll always be named 4 or 10 because the half release comes out in October.
And 4 is always the long-term release, right?
Yeah, and this is a long-term distribution. So Ubuntu commits that they will support this version of the operating system for 5 years, and that's great. The one before that was 16.
I had no idea that was how that worked.
Yeah. So
This is the preview release for the next.
So the previous distribution of Ubuntu was 16.04. 16.04 goes out till 2021. So you get some overlap here in the support. So while you're still supported on 16, you're still supported on 18. So theoretically, you got 3 years to switch your 16.04 systems to 18.04, and then you're still in that nice, fat, and happy support cycle.
Can we purchase extended support so we can run 16?
I'm sure you can. I'm sure you have. All right. So my Red Hat 5 system that went out of support last year, we bought extended support for till 2020, and they'll probably do it till 2022. Who knows? But yeah, it's nothing that money can't solve.
Boy, let me tell you.
So yeah, fire up Ubuntu 18.04, and man, is this thing different from the original 16.04 install. It's completely container based. Even the kernel is in a container. It uses a different package management system called Snappy. They don't actually use Snappy. It's just Snap install something. Previously on Ubuntu and Debian, you would have to do an app. The program was called apt-get install, and then whatever the package name, and then it would hustle out the internet and get you that package and install it for you. Which was a wonderful thing. Beats going to Best Buy and buying shrink wrap software. But they switched all that up and gone to Snappy, and Snappy is container-based package management. It takes the base system, which is only about 400 megabytes for the entire Ubuntu base system, and then just says, okay, you want Nginx? Okay, we'll just slap that on, and so the new install is just the base system plus that container. And if you do go into a process tree and look at all the processes running, there's only two. There's the base system, and there's your Nginx container, and that's it. So this is a big evolutionary change, and Ubuntu would not have done this. They would not have done this if they didn't think it was going to work. And they've been doing this nice thing, since 2005 at least.
Yeah. It's been some years.
So they've been doing this for 13 years. And Mark Shuttleworth is a guy who leads Ubuntu, primary investor from South Africa. So they're pretty smart guys. They got all the gearheads that you would want on a project. And so if they have done this, and I think they're going to take the lead in operating systems over Red Hat. A $1 billion company giving away its code for free. Over CentOS, which is just a derivative of Red Hat, and Oracle Linux, which is another derivative of Red Hat. So this is big news, and I'm still learning how to work with it, but it's out there, and they've chosen to just go fully containerized for their whole operating system. All right, now that said, back in around 1965, 66, Fred Brooks and IBM basically bet the whole company on the IBM System 360, and hoping that was gonna be the thing to save the company, and it was, but it wasn't on time, and it was way over budget. And Fred wrote a book about it called Mythical Man Month, and then he said, adding more developers to a project is just going to make the completion date of the project go out there farther. And the analogy is that if it takes a woman 9 months to make a baby, 9 women will not make one baby in 1 month. And years later, he wrote a follow-up paper called No Silver Bullet, and it's the same thing. The old is new again, and there's not going to be any magical fixes. I think containers are great, but it's still a big infrastructure change. It's going to take people a while to switch over to containers, just like it did to go to VMware and KVM. And this is going to be no different. You still got to do monitoring, you still got to do backup, and you still got to do failover. And those things are different when you're dealing with containers, primarily because you're not jumping inside the container to run an agent. You're having to monitor it from outside.
So your standard things like Nagios that you might have doing internal.
Yeah, you're not going to have a Nagios agent. I guess you could put it inside there.
But you'd have to have a specific config for each.
Yeah. So these are things that have to be figured out. Now, a lot of people ask, okay, this Docker thing, is it cross-platform? Well, yes, kind of. Because this might be hard to see in the back, but you got 3 boxes here with native Linux on the left-hand side. You got boot to Docker in the middle for Mac and Windows hosts, and then for Vagrant VirtualBox, you got 3 layers. You got the host OS, and then you got VirtualBox VMs sitting on there, and then inside the VMs you got containers. So you do have cross-platform, but they're all based on the Linux kernel because Docker was written for the Linux kernel, and just because it's fast and efficient and all that and open source. Yes.
So what about Windows Docker containers? How do they?
They're based on Linux VMs, just like this. They're going to boot on a boot to Docker Linux image, and boot to Docker is going to be the one that loads the containers.
So boot to Docker is basically some sort of.
It's a very small Linux machine. Boot to Docker is a very small Linux machine with just enough operating system to run Docker. And off of
But
that,
like the Windows applications that you run
Yeah.
in Docker.
yeah, if you ever mess with VMware and you go into the host operating system, you'd be like, and you're used to Windows, you'd be like, what? There's nothing there, and
Well,
that's
I guess-
true. There isn't anything there because
So could you run something like IIS, not ISS, that's space station, and that would be awesome to run in a VM. But something like IIS, could you run Microsoft native application with Docker?
If somebody has figured out a way to port it to Wine.
I'm pretty sure Azure has a magic version of Docker that does that. That's part of their Azure build out is you can actually deploy a Docker instance and you can push button receive container of your app. So it's out there.
Yeah.
I'm not sure if it's actually based on IIS or if it's actually running like Apache under the hood. But because I mean that's the way Microsoft does things in Azure. Like we couldn't figure out how to make this work with our technology. So here, have this Linux variant.
We know this works. Let's just.
Right.
I'm trying to be I am the lead of the Linux user group, but I'm trying to be platform agnostic here. I spend a lot of my time in Windows, so
Sorry.
there's that. Orchestration. Okay, so how do you do? Okay, so again, Docker is cracked. So when you get your first hit of crack, you're going to want to do a lot of it, and so pretty soon you got a laptop with 100 containers on it, and you're like, well, how did this happen? I need a sheep herder or something. The saying is, you're currently taking care of pets, but you want to be taking care of cattle. Okay, so instead of putting a lot of time and attention into your cat and your dog, you've got 2 is fine, but once it gets to 100, then it's too much to manage, and you need a cowboy on horseback, yeehaw, and go that way, and that's it, and that's what you want. So you need an orchestrator. That's what that thing is called. And so Kubernetes is the orchestrator that has basically won. Docker came out with their Swarm with great features like Docker Compose, and then Google decided, hey, this is going to be really big, and we just need to own it. And so they pulled Microsoft and just open sourced their Borg application as Kubernetes, and now it has taken over to the point where Docker has just admitted it and says, okay, we're going to go with Kubernetes. So, and that was just last year that happened. So everything's still very, very new in this space, and it's not going away. But it's if you were just starting to get involved with containers now, and it's not a choice anymore about whether you use Swarm or Kubernetes. You use Kubernetes. So yeah, there's that.
And
Docker's yes. Yeah.
Just to add on to the bandwagon, so I'm being texted by a coworker that apparently the Windows 2016 exam includes Docker and containers. Like it's part of the 2016 Windows examining process. So
There you go.
like
Can't get away from
Microsoft's like, yep, no, we give up. Docker. Fine, Docker.
Yeah, so it's getting pretty popular. When Joe Brockmeyer, Zonker is his handle, came to Southeast Linux Fest a couple years ago. He was under the weather, but he gave a presentation on Docker, and it was like, of all the open source projects I've ever seen in my whole life, this one is taking off faster than all the others. And it's just because they had containers before, but Docker just made it so easy to create containers that everybody did. And now that creates other problems, but everybody's using Docker. Okay, so Docker security. All right, Dan Walsh of Red Hat had a great. He has a great YouTube video out there as kind of Red Hat's response to Docker and explaining how things are running. And good old Dan, he's the author of SC Linux, by the way, package that secures Linux and makes it a lot more security conscious. Good old Dan says, hey, containers don't contain. And he's right about that. If you get root on a Docker container, you got root on the whole box. I mean, and box by I mean the host in which all the other containers are running, Ford and Chevy and Mazda. So Ford can read Mazda's data and Chevy can read Ford's data, and if they were running on the same box. But yeah, you get the idea. Not what you want. So Diogo Monica. So I mean, Docker heard these criticisms and they said, well, we got to get good on security, because originally, that was the only way to run Docker. You ran as the root process, which is the admin user in Windows terms, and that was true. If you had crappy security and somebody got root on the box, then every other container on the box was
Spend
compromised.
as many containers you like, I still have root.
That's right. So Diogo Monica responded to that with a Docker video, a really good one. This is like 8 minutes long, and we're going to watch it as a response to the first video we saw about all this about the Hitler rant, and all that stuff. I agree with. Whenever I start something, I try to look at the worst case scenario and then go up from there. So, and this is one response to that.
Laptop's about to die.
Oh, did it? All right. All right, Corey. Help.
Corey.
Been replaced.
All right, Amy's finished. This is on the way. Your battery's about to
get around. It's crazy. So that's one way. And you notice he had to go to the temp directory so that he could write a bunch of log files and the process ID file and a few other files just to get everything to run okay. Other applications would probably require a little bit of the same editing food. So
Hey, Ben.
so there's that. Yes.
Alex actually had a question.
Hmm?
Right. So I was curious, Jeff brought up the point that log files, we best practice to store those somewhere, third party offsite, so that they don't get erased every time you reboot the system, as they would in temp. And I was curious if you had a central log source where if you're running 30 containers simultaneously and they all send their logs to one central location, how would you later go back and parse through that repository for a particular container? How is it organized?
Well, the two popular packages right now for central log management are Splunk, which is proprietary, and then the ELK, which stands for Elasticsearch, Logstash, and Kibana. That's the open source version, and so you would use one of those two packages. I don't know if Splunk has a container, but I would be astounded if they didn't. So it's probably on their website somewhere. I would think it would be in Docker Hub, because I don't think they could figure out a way to charge for it.
But I think Alex's question is more speaking to how do I tell that I've got looking at a log in ELK from a specific container versus how do I know I'm looking at container 15.334 instead of 12.389? Like, how would when a container spins off, does it get its own unique identifier, or?
Yeah, it does get its own unique identifier. If I switch to
Oh no! Did you sacrifice a small furry thing?
all right, here's my process list right now, and you can see that. All right, so every container has got its own container ID, and we got 10 containers running here, by the way, and they've been running in the background for 4 months. I didn't even know about it. You should have seen the ones I did kill.
Battery life.
Oh yeah, this was my I was poking around with ELK stack, and there's Kibana, there's Logstash, there's Nginx.
So that container ID would generate. So if you restarted one of those, you would get a new container ID, right?
Yes.
So
yeah, you'd have to.
So again, I guess, is there a name so if let's say we ran up 2 Nginxes from the same everything except basically had a different index.htm file, or HTML file, would they have persistent unique names that we could correlate in a log to identify which container?
Yeah, I believe so.
You can assign it a name when you start it up.
Yeah, I mean,
Yeah,
see,
there's a name at the end of that line.
See the names column right here.
Okay.
benf underscore nginx underscore 1. That's the name of that. That's the friendly name of that container. That's still unique. If you pull from Docker Hub, the container name will be just 2 random words put together with an underline sign, kind of like Ubuntu does with their name, Hardy Heron, like that. And so they do the same thing.
So if I'm looking at syslog, the host name from that source would be benf underscore nginx underscore 1.
That's right. Yeah.
Okay.
And then if you spun up another container, it might be nginx underscore 2.
Yeah.
Delightful. Okay.
Fantastic. Thank you.
So
More questions.
Yeah, I just had a question about, so if you're running an application as root with Docker, what all has there been, other than, I know there was an exploit a few years ago with Docker socket. Do you expose Docker socket to the container, you can do pretty much what you want to with it. And there's like a Metasploit module to abuse that. But what all can you do with the host system? Because I know you can install whatever packages you want on that container. You can do whatever with the container.
Right.
But assuming that the other containers nearby are secure, you don't have the Docker socket exposed. You're not running as privileged where you can load kernel modules. What all can you do with that?
Basically, run the smallest operating system you can find that will actually run Docker. It's the same way VMware does with their operating system. It's just a really small footprint, small attackable surface that you only have to update maybe 10 or 20 packages to keep this thing secure, which beats 1,200, 6 ways a Sunday. And don't run a web server on a host. Does that answer your question?
Well, I think one thing that you could potentially do, and this is just, but if you can get back to the host,
If you can.
so you get back to the host, you may not be able to modify another Docker container that's secured, but you may be able to modify what it's based on. Because you're now
We modify the config files.
So as soon as they redeploy, you've now redeployed something to that new container.
Oh, the config files that, like say you share some files with Docker, it's immutable. Like you make changes to it in the Docker, the original files aren't changed. So.
No, but what I'm saying is if you get back into the host operating system and you have root on the host operating system, you can modify what the Docker containers are based on. So if they ever get regenerated and rebuilt, then you can push
I
out.
get that. I was just saying, like, is there any known exploit for breaking out of the Docker container and doing this? I know, like, best practice.
I'm not sure.
Well, a known exploit right now is just having an Intel-based architecture.
True.
So, I mean, how many organizations are still affected by that today because it's so hard to implement changes when the literal beach that you're standing on it just falls right into the sea. I don't know. Small footprint, small image. That's what I have to go with.
And you could spin up another container of your own that you could host whatever you want. Now it's coming from a trusted source because maybe this.
Well, if you have access to the Docker socket, you can do that.
Okay.
Yeah. Any other questions?
I think we're done interrupting you for the moment.
No, I'm not.
I think I'm doing it. I just got references and resources at the end. Corey?
So going way back to your slide about resources and how the containers share resources. So how does that work out? So on an ESX host, you give a VM either dynamically allocated or statically allocated, right? You give it so much RAM, so much CPU, so much disk. How does that work out with containers? Is it that clean, or what's it actually dedicated? Is it, you know what I mean? It's like, is it like a virtual machine, or is it different?
Well, if you ever mess with a Linux box in Etsy/security, there's a file called limits.conf. And in that file, you can set a whole bunch of tunable parameters that you would normally find in syscontrol.com. Like the number of files that they're allowed to be open at one time, or number of processes that any one user can run. It's like that, except there's a namespace just for that, just for this Nginx container, and so the Linux kernel designer says, "Hey, this limits.conf is really good, on the whole box. Let's just, this whole VM thing is all the rage. Let's make it available to the containers that we're going to build and the LXC subsystem that we're building."
So if you were wanting 4 web servers and no web server could use more than 2 gigs of RAM,
Yeah.
you would make a change so that in that limits.conf so that you would only allocate that to the Nginx process.
And that's a Kubernetes job really as an orchestrator to say, oh, I've got all these cattle, and no cattle can get bigger than 2 gigs of RAM, something like that.
No, and it doesn't. One thing that I was thinking is that containers like create more space or give you more resources, but that doesn't sound like it better allocates available resource based on your whatever config you set up or how you have it set up.
It's about application density. How many applications can you get on one box?
Right.
Remember when we had IIS running on one physical server and I was only eating 1% of the CPU, but all the servers on one physical box through VMs, and then they were taking up to 60 to 70%, and that's the way you want it. That keeps it manageable and creates the application density on that server.
To really warp your brain around about like how you can scale this out. So imagine you have a server OS that comes preloaded. The image comes preloaded to pull down all of the latest Docker code. So you've got code for a bunch of different Docker containers. So one for every one of your apps. So then you spin up a server, spin up as many instances as you need to get your apps up and running. Well, if you identify that you need more load for more Docker containers for a given application, you spin those up. Well, if that server's out of resources, you spin up a clone of it right next to it. And you start spinning up containers, and you can do that ad nauseum. And each server that comes online already has all of the different containers that it may need to add additional resources to your application. It just joins the party as it so one server might be running 30 containers of the same application, but the server next to it is running 7 different applications in different containers. So you can get super immutable or super mutable around how many servers you have spun up for a given application at a time, but the code never changes.
When you say servers, are you talking about VMs? Are you talking about hosts? Or are you talking about?
I'm talking about Docker hosts.
Okay.
So and I'm imagining that you've got tons of bare iron running around that you can run VMs on, and you're spinning up a VM that runs Docker containers. And instead of having to scale that guy out to have 7 terabytes of memory and all this, you can just spin up dozens of clones of him that can spin up as many containers as they need. So you kind of got nested containers inside of VMs, but you're spinning those up ad hoc as you need to.
Right.
And that's sort of how cloud apps are delivered now.
You have to have something on the front end that is taking your incoming request and forking it off to one of
So
the
there-
Right.
there is
a load balancer.
Somebody is acting
You gotta have
as
a load
traffic
balancer on the
cop,
front end. Yeah,
but like on the back end,
you
it's
spin things up as you need them.
right.
As some instances that we've had multiple web servers hosting different apps, and we've had to deploy a proxy server,
Right.
basically a reverse proxy that takes any incoming request and then says, oh, you match this internal Docker host or this Docker container and go here. So we have had to have that orchestrated as well.
Yeah, I mean I didn't do a good job of explaining this, but Docker, all the containers on a Docker host are running off of one kernel, whereas with a virtual machine situation like with VMware or KVM, you got for example, I have 17 on average about 17 Linux servers running on one physical host right now in KVM, and I have some in VMware. But that's about the average. But that's 17 entire operating systems taking up resources on that box. In Docker, you just got the Linux kernel running, and then each application has just the binary and just the libraries that come with that application, bundled up into one container that doesn't contain, remember? And it's in its own namespace. It's got its own control groups to manage the CPU, memory, and the disk, and all that you would normally associate with a VM, and that's it. So not having the other 16 operating systems on that box frees up a whole bunch of resources for running more containers.
The trade-off on that, of course, is that since they're all together, if you do have a way to get out of one container, you're more vulnerable than you would be if you had separate virtual machines there.
Yeah, exactly. Yeah, if the kernel somehow got compromised, then ball game's over for all 300 containers in that box.
So why it's important to do the stuff in the video and
Amen.
make it not run.
Yeah. So.
But I mean, the trade-off, the other side to that is you never have to worry about downtime to do things like updating your servers because, well, you can spin up a new VM and update it before you launch any Docker containers, migrate all of your running Docker containers to it, and shut down the other guys. And then you can discard those servers because you don't care about them. Because you're just going to spin up a new clone, fire up new Docker containers, and hey, look, we're off the races.
Yeah.
Like it's this. Like servers become disposable in the Docker universe, just like containers become disposable.
Yep, absolutely.
It's a wonderful, terrible world.
So take the example of the spinning up Nginx or a bunch of web servers, for example, and say they all have some central data they need to access, or that's on a file system somewhere. Are you mounting that file system into the containers?
Yes.
That's okay.
Yeah, the problem comes up, if you're going to kill these containers off, isn't the data going to die that's inside of it? And the answer is yes.
Yeah.
So the data's got to be outside. It's either got to be on the physical host or on another server, some NFS server or DFS server in Windows land.
I assume if it's on the physical host somewhere when you start up or configure the Docker container startup, you can say, hey, share that folder or that hard device or something like that.
Absolutely, yeah.
Okay.
Yep. So you just got to think about that ahead of time. Where okay, I got a database container here. Where's my storage going to be? Because it's not going to be inside the container because you got a 6-gun and your job is to shoot containers that are behaving bad.
Does that, in and of itself, I guess that becomes a point of, if you can compromise the data through one container, then you can compromise that data for anything else that shares it.
Yeah.
So,
Yeah, absolutely.
Shared resource. Yeah.
So this is a way to kind of mirror a whole ecosystem of machines. And what do you guys do here? You build battleground servers with all these VMs. So that entire setup can be shrunk down to a laptop. How many 7 megabyte Nginx containers could you spin up on a laptop? All on separate ports, and you're like, hey, I've got my own capture the flag on my laptop.
What have we been doing?
404 Pendleton Street, Thursday nights.
actually, so that actually is a good question because it is a mind shift in how you're providing those services, and it's a different attack surface. So traditionally, it's been the VMs that we would set up in Battlegrounds are going to replicate bare iron or VMs that you would set up in an enterprise, and the attack surfaces that are there, and that is a traditional security focus and is something good to continue with. But I also think that trying to come up with a server that's set up with Docker images, and those applications can be compromisable. They can have vulnerabilities, and I think it would be a good thing eventually within the Battlegrounds to have that kind of testing environment. And that would be something that not a lot of people are doing in that environment. So,
Compromisable? You just got to pull from Docker Hub.
They're good, like vendor support, just general documentation, or you're pretty much on your own for doing this?
Well, Docker, the project is open source, so Docker has to go on the Red Hat model of selling support and the entire ecosystem around Docker. Not the container company that is providing space for Docker images is DigitalOcean. I don't know if Docker owns those. Do they?
I don't think so.
Yeah. Okay. So it would have made a lot of sense. They could have sold a lot of VMs that way. anyway,
Well, I mean, DigitalOcean does provide VPS and all sorts of services above and beyond that. So
yeah, and Docker will provide you support. You just got to call them and then give them a credit card.
As popular as the Docker platform is, it's not like you're going into Azure where Microsoft wrote a bit of documentation. There's tons of documentation out there on how to get something done. So,
and the support fees are going to be typically, because we've looked at enterprise licenses for a lot of open source stuff. If it is a true open source project, then it's going to be less than what you would pay Microsoft. An
yeah,
equivalent
it's not written fees.
service fee. But if you go with a third party who is using that open source software, then you're going to pay Microsoft money for it.
Yeah.
So it all depends on who you get to do your support. And there will be a lot of people out there offering support.
There is one other orchestrator I wanted to show a little bit about called Mist.io. It's a container / VM management company that started in 2013 and says they can manage containers and VMs at the same time in a heterogeneous environment. And then I said, well, that's exactly what I have. let me try that out. So I got it installed on the laptop and just see how. I know Docker Swarm isn't a thing anymore, but that's what they were using at the time. So if to get this running, I would have to change directory into the Mist.io container and then do Docker compose. Again, this is a compose Mist, I believe. Oh no, it's complaining. Start. This. Oh, come on now. What was that?
Just do up.
Oh, here we go. So these are all containers that came with Mist, and takes longer for some to start up than others. It's probably waiting on Elasticsearch Manage. That's a big package. Elasticsearch is the combined with Kibana and Logstash is the Splunk alternative, which allows you to log to a central repository. Now this might bomb up.
I asked if you sacrificed something small and furry.
Looks like I did. All right, so that's all I got. We can don't have to watch that. Any other questions? Probably. Yeah. So yeah, there's lots of tutorials on YouTube for watch getting this stuff down better than I presented here. But hopefully that whetted your appetite and you'll give it a try in Hyper-V.
So long story short, you're basically saving cycles, right?
Yes.
You're carrying
Absolutely.
that, like you're using your example, you used to buy bare metal servers, spin them up, run IS on them, and use 1%. Then we moved to virtual VMs where we put multiple VMs per bare metal, and we use 60%. And now we're going to the point where those VMs were maybe been utilizing 10%. We're now going into that and now utilizing.
And instead of having 100 VMs that are the VMs independently are sitting at 1 CPU or 1% CPU cycles, you're now taking that VM and collapsing all 100 of your apps onto that guy, so he's fully utilized. And then when he's tapped out, you spin up another guy right next to him that can do the same things he can do, but you're doing it all in software.
So from the administration, like management standpoint, where's your point of diminishing returns? Because at a certain point, like I get hyper-converged, I understand all that, but at a certain point it doesn't make sense, right?
Well, no, but the whole idea behind it is that, and this is something I wanted to talk about anyway. So in this universe, the whole idea is you rapidly spin up containers running new code, right? So in the development environment, you don't have to bring down your application, update the code, and bring it back online. You can literally have both the current version and the new code that you want running active at the same time. And then as you decide, okay, the users are happy with this is actually working the way I want it to, you let the others die off and you replace them with the new code that you've got. So you're continuously updating. This is how like Facebook and Netflix, this is how they update shit. They've always got a container running somewhere that's presenting their application forward. They're just swapping the application out with new versions of the code. And if they deploy a version to a handful of containers and it really doesn't work, they just roll those back and nobody's any the wiser. Those handful of users that had a bad experience, but they come right back and it's back to what they expected anyway. So the whole idea is you've got the host servers that are running your containers. You can bring one down and update it and bring it back online, but you don't even do that. What you do is you have a golden image that you're deploying your servers off of, and you update your golden image so it's got all of your Windows updates on it, and then you deploy a new container host, spin up containers on it, and then let your others die out, and you spin up new ones, spin up new ones, spin up new one, and suddenly your whole infrastructure has been updated in minutes. And no user realized that anything changed because the container they were on served them, and then when it was done serving people, it killed itself. And that container closed out, and it got spun up somewhere else running the new code. And so it's all super high-speed, iterative development. The reason I say all that is if you think back to some of the talks you've had previously on integrating security testing into software development lifecycle, it's sort of depended on testing your code before you put it live on the internet. But that really kind of breaks in this model. And you have to get down to a more integrated, continuous testing model where you're constantly poking at your own applications from a web security standpoint, trying to break into them because the code's constantly changing. And that's the whole idea behind this. That's why everybody's going to it, is because developers can like fix stuff as they see it, as it's reported. They can get really, really rapid turnarounds, and it doesn't make sense to go through this whole process where they're going to develop code, fully tested, fully vetted, and then have it in some major version release. That doesn't happen anymore. They test, develop, and vet, and then deploy like in a week instead of over the course of 3 months.
The case management lifecycle is gone.
Right. It's a completely different model, and you need to understand that if you're in an organization where you deal with that from a security standpoint, is you've got to beat that challenge. And it's there. You can go look up doing web security testing in the Docker universe because there's stuff out there on it. It's way more than we have time to get into right now, but it's a really good read.
And then think about large companies like Oracle. I know organizations right now that are patching Oracle databases that they haven't patched for 2 years. Can you imagine leaving a WordPress site up for a month without updating it? Can you imagine how owned you would be? I mean, and there's nothing magical about Oracle code. It's just as hackable as anything else out there as WordPress. So they're going to be left behind in all this. I would not go into Oracle database administration class or anything like that. Well, even Oracle's starting to get it. They're starting to talk about these plug-in databases, which is just another name for a container. So they're starting to get on track, but it's been a long time coming, and they're going to get eaten.
What databases would you recommend using? Containerization.
Well, from last month, LMDB looked really promising, but that's just a key value store. If you want a relational database, then you would want to go with Postgres or MySQL, both open source projects. Postgres having the better reputation, having been designed by Michael Stonebreaker, database guru. But there's all kinds of others. I mean,
There's also like MongoDB.
MongoDB, Key Value Store. Yeah.
Like, oh god.
It depends on what your problem is. If you have a relational problem, then you use a relational database. If you have a key value problem, then you use it.
I really feel like the database universe sort of has been quantified by the XKCD on competing standards. There are 14 competing standards. This is unacceptable. We need one standard to rule them all. Okay, there's 15 standards. Rinse and repeat forever. And there's a database out there that does all the things you need to do. And it's going to do that right up until a point when it doesn't, and then you're going to switch to another one. So this is my really jaded view of it. Go with whatever makes sense to you at the time, because it's going to break eventually, and you're going to have to change it. So,
yeah.
I mean,
And try to get your developers to not write code that is very specific to that database,
right.
because they get to rewrite it later, and that's no fun for anyone.
Yeah.
Good time to introduce new bugs and all that.
How many developers do we have here, Bowen?
At least
Right.
2 of you.
So I mean, you guys especially should be making a beeline straight to your sysadmin and say, when are we going to implement containers? When are we going to implement containers?
Our developers have been hammering us about it
I've heard that
constantly.
It should
I've heard
be.
that drum before.
And why is that? Because if it works on your laptop, it's going to work in production. How many times has
It's the
it
same
developed
thing.
develop on your laptop, hey, and then, it breaks in production and they come back to you and say, why did it break? Well, it worked on my laptop.
Right, the environment's different somehow,
Yeah, right.
and then you have to spend hours figuring out, well, how?
But
What's
you
the-
put those libraries together. You put the binary together. You put those libraries that support the binary, and it's all contained in that container that's hashed. You gotta
And
gotta check some and everything. Can't be changed. Put in production. It's gonna work.
It runs the same way.
It's gonna work.
James, questions you guys do.
I have so many I can't. I don't even know how many credits I have. I just know that I have them.
Hey, if I had known Docker
I
was
can't
gonna be,
articulate them.
if I had known Docker was going to be this big, we'd have done a longer session.
And you only have to spend hours looking at your environment if your firewall admin's bad. I know from personal experience.
Hi,
I'm a firewall admin, that's me.
I've spent a lot of time trying to figure out the difference between somebody's development box and that production server, or the development box and the boss's laptop.
Right.
Yeah.
Because, when you install Visual Studio tools, it installs these other libraries that we didn't realize wouldn't be on every machine. Oh, they're on most machines because somebody else required them, so we happen to pull them in. But if you have an absolutely clean one, it's a little different.
Yeah.
Yes.
And Kubernetes is important in all this because it's taking care of the high availability. It's not just starting one Nginx container. It's starting 3 on 3 separate physical hosts.
And so
So
to
one goes down.
demystify,
Yeah, I need to learn more about it.
to demystify some of how that works, there's a load balancer sitting in front of that, right? So you've got an IP address that your web service is running on, right? Well, Kubernetes has spun up all these little VMs on the back end that are part of that cluster, right? Well, either the containers are going to respond on the bit, which is unlikely, or there's some device sitting out in front of those containers that's waiting for requests on that IP address, and then knows, okay, well, I've got all these containers on the back end that can respond to that request, and it just sits there divvying them up as they come in, round robin fashion.
And if you bring up that new one with new code, maybe you only want a certain percentage of requests to go to that.
Exactly.
You should be able to tweak that in the load balancer.
Right.
See that, enough people seem to be happy with it. Okay, I can bring down old ones, bring up new ones.
So Kubernetes is what handles some of that orchestration.
Yes.
Okay.
Yes.
That answers some of my questions.
So we've been working on a CTF for USC, and I've been looking into using Kubernetes to host it all. Like potentially have a cluster for every single team competing. Is that a terrible idea?
No, that's awesome.
That's not a wretched idea, though.
Because I haven't seen a whole lot, like a handful of CTFs have done it, but then like one of the CTFs, I think is like B-Sides, somewhere in California, like they misconfigured their security settings, and so like someone had pulled the entire competition within like 5 minutes.
Right.
Uh,
So, yeah, I think that has way less to do with it being a fantastic or horrible idea, and much more to do with how much expertise you have with the technologies that you're using to run your CTF.
Well, Kubernetes, not so much. But
So
I've been learning.
if that's what you know the most about, then absolutely that's what you should run it on. I just, if you're planning on running a thing like that where you want to make sure everybody stays in their swim lane and there's not a secondary competition going on to see who can hack your infrastructure, then it's probably best to stick with other technologies. But hey, it's also a CTF and it's supposed to be fun for everybody involved. And if you had fun putting it together, then hell with it. Go nuts.
And remember, that changes the game entirely, because think about it. All right, you got this host with a bunch of VMs on it, like 17 VMs, I said before, and then you got another host with Kubernetes on it with 300 containers, immutable containers, by the way. What are you going to attack? And over here, you're going to attack the VMs. Over here, you're going to attack the only thing that's changeable, which is kernel. You're going to try to attack the memory some way, maybe get at the memory through the containers, maybe the containers expose the memory space some way. Maybe the temporary file system on the containers is mounted on the host, and maybe you can get it that way. Stuff like that.
Yeah, I was thinking of like having some vulnerable service running into a container, and then like they hack into the container or whatever, and they find the flag. And,
Yeah, they
that's
hack
it's
internets and
Yeah.
Okay.
That's totally viable as a concept.
That container, when you say that container is not writable, the original source of it is involved,
Yeah.
like the original thing
Right.
that's being spun up with Cal files
I mean,
on top of it is not writable.
Here's the thing.
If you get into the container, like say somebody runs SSH in it, you get in there, you can mess around. While that's running, you can change how the application may be behaving there until they spin the container back up and then it's gone. Is that
Yeah, I would wonder how they got into the container, because
right? But
You
if
need to log
hacking
in
into
something.
well, if there's a flaw in Nginx, for example,
Yeah,
you
yeah.
get a shell in there
Yeah.
to drop you inside.
So, you're pointing at containers, if somebody does get into it and modify it and acts in a different way than what you would expect, can you kill that container and have it dynamically?
Yes.
Sure.
That's the desired state.
Right. But
However they got
just
Right, yeah. lose
that,
that.
just remember, you spun up your vulnerable
Yeah, exactly.
code again.
Right.
That you got to figure out how to stop them getting in, but
Right.
you can
You can
leave the
turn it into a
damage
denial
and
of
like
service.
every time they own
Right.
it, kick it over, kick it over, kick
Right.
it over, kick it over until you deploy the new code that they can't kick
In
over.
my brain, that's the same as running up to a physical server and yanking the network cord out of it. Sure, your server's still vulnerable, and when you put it back online, they can get back in, but at least whatever effort they went through to get there.
You can flip the power a lot faster.
Right.
Yeah.
You made them go, oh, crap, all right, well, let's start over.
Clearly,
They're-
the best way to fix this is a blacklist of IPs that are hacked.
Sure, yeah.
Yeah,
Give you a
'cause
little more
those
time,
work real
please.
Yeah.
So there are actually projects online to integrate like with Palo Alto and have Palo Alto detect an incoming threat, realize that a VM's been owned or a container has been owned, and bounce the container.
Will the PA go to container level?
No, the PA doesn't have to. The PA just fires off an alert that says it sees this indicator of compromise on your container. And then your Kubernetes instance on the back end consumes that and says, aha, bounce.
And the PA would capture the container level info.
No, the PA doesn't know container. All it sees is IP, and it
Right.
sees a connection. But Kubernetes can interpret that and tie it back to a container.
Because the containers will be dropped to a certain port.
Yep.
Okay, all right, now you're on the again, sorry.
So
You're straight into my role.
this last slide is just the resources I used to put together the presentation. I know I got blue on blue
Nice
here,
blue
but
on blue there, buddy.
I LibreOffice cannot, for the life of me, figure out how to change it. So anyway, but just search for Diogo and Docker. You'll get 'em. And Hitler uses Docker.
That one should be memorable.
Yeah.
Severalnines.com.
Yes. I mean, this is a good site to go to, but they've got some add-on in there that just takes my laptop into the stratosphere, and it's a really stealthy ad too, because your CPU doesn't go up on the monitor, but the fan's going crazy, so I know it's doing something. So I wonder about that. See?
No, I need Bitcoin.
Right.
That's what I was thinking. Oh, there goes another $50.
Yeah, you're increasing your power bill to lower someone else's.
It's the shared economy.
Well,
All right.
thank you all for your attention.
Thank you, sir. Thank you very much. Okay, are we doing the raffle thing? Let's do the raffle thing.
We should have done this.
You learned things.
It's terrible.
I can tell that you learned things because of how much you're bitching about
I'm
it.
angry. I'm very, very angry right now. Very, very mad.
I learned things before we even got into the meat of like what's going on with Docker. So I learned things I didn't know about Ubuntu.
Right.
That was version 18.